Hello class, today we are starting our unit on rational functions, and today we're specifically going to be talking about how to solve for x when dealing with rational functions. So let's first off and define what a rational function is. We worked with them before. A rational function is any function that has an x in the denominator. So remember when we have something that is being divided, we have a numerator which is on top and a denominator which is on bottom. So basically all of these functions are going to be fractions of some sort, and we're going to have an x on the bottom, or x and a something on the bottom, as long as there's an x on the bottom. So here are four examples of rational functions. 1 over x is a rational function. X squared plus 2x plus 1 over x is a rational function. And then we have stuff like x plus 3 over x minus 9, and 3x divided by x squared minus 6x plus 2. So notice that all of those have an x and or an x and something in the denominator. So that's what makes a rational function rational. We get the word from ratio, right? A ratio is a multiplicative comparison between two things. So let's talk about how to solve for x when we have rational functions in equations. So our steps, first step is we always like to try to get rid of any fractions right off the bat. So if you can get rid of fractions, do that. And in this case today, with what we're doing today, you'll be able to get rid of fractions right off the bat. Step 2, simplify and then move everything off to one side so that one side is equals 0 equals whatever we have. And then step 3, we need to solve for x. And if it's quadratic, then the quadratic formula will work for us. And in this case, with what we're doing today, all of them, once we simplify and move everything off to one side, they're all going to be quadratic. So we'll just apply the quadratic formula for all of these. So let's take a look at this first example here. We have, in fact, well, this is a rational function and it equals a polynomial, right? And notice a rational function is just made up of a polynomial divided by a polynomial, actually. So kind of going back to last unit a little, we're just building off of it. So we have 5x plus 2 divided by x plus 10 is equal to x plus 1. So let's kind of go through these steps and try to navigate our way through this problem. Step 1, let's try and get rid of any fractions. So notice that here on the left, 5x plus 2 is being divided by x plus 10. So how about we try the opposite operation and we multiply both sides by x plus 10. So what that's going to do is that's going to cancel out this, and now we're left with 5x plus 2 is equal to x plus 1 times x plus 10. Now, let's simplify this right side. Looking at step 2, let's simplify the right side. And then once we have it simplified, let's move everything over onto the right side. And then we'll be able to solve for x. So here you'll notice that we'll have to, we're going to multiply these together. And in doing so, we're going to have to FOIL. So we're going to multiply the x to the x to the 10, and then do the same thing with the 1. 1 times x and 1 times 10. So let's go ahead and do that. We're going to have 5x plus 2 is equal to x times x is x squared. X times 10 is 10x. 1 times x is just x. And then 1 times 10 is plus 10. And then notice, remember, this happens very often when we FOIL things. We have two like terms, so let's combine those. So we'll have 5x plus 2 equals x squared plus, let's see, if we have 10 of something plus 1 of something, we'll have 11 of those somethings plus 10. And now let's move everything over to one side. So it'll probably be easier if we move everything to the right side. If you wanted to, you really could move it to the left, but let's move everything to the right. So notice we have this 5x and a positive 2. So how about we subtract 5x and we subtract a 2. And so what we do to one side, remember, we have to do to both sides. So we're going to subtract 5x from 11x, and we're going to subtract 2 from 10. Remember, we can only subtract or add like terms. So make sure you're subtracting from the like terms. The x's from the x's, or the constants from the constants. So now here on the right side we have 0 equals x squared, nothing happened to the x squared. And then we have 11x minus 5x, which is 6x. And then we have 10 minus 2, which is 8. So we just finished step 2. We simplified and we moved everything to one side. Now we can solve for x by using the quadratic formula. And I'll write it so we have it for reference. So let's remember our old friend, the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac over 2a, when it's in this form. So notice a, remember, is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant value. So let's go ahead and define, using this function down here that we have, let's define our x value, or sorry, our a, b, and c. So a is the coefficient of the x squared term, in this case it's 1. B is the coefficient of the x term, so it's 6. And c is 8. So let's go ahead and plug that into the quadratic formula, simplify, and see what we get. So we're going to have x equals negative b, so negative 6, plus or minus the square root of b squared, so 6 squared, minus 4, the 4 is in the formula, times a, which is 1, times c, which is 8, all over 2a, or 2 times 1. So let's go ahead and simplify this. Remember, we want to simplify this just like how we read a book. Start from the top left, go to the right, and then simplify the bottom. So, and it's going to take a few times to simplify this completely. So let's just do it one step at a time. So we have negative 6 plus or minus the square root of 6 squared is 36. And we have negative 4 times 1 is still negative 4. Negative 4 times 8 is negative 32. All over 2 times 1, which is 2. And you can see this thing is starting to look a lot nicer. We can still continue simplifying under the square root, so let's do that. X equals negative 6 plus or minus, see, 36 minus 32 is 4 over 2. And remember, if we get to this point and we don't have a perfect square root of the square root, we can leave it just like this. However, for today's purpose, all of them are going to be perfect squares. So let's go ahead and take the square root of 4, which we know is 2, or positive or negative 2, and continue simplifying. We have negative 6 plus or minus 2 over 2. Now remember, if you recall, this is where we want to split our equation into 2. We're going to have a negative 6 plus 2 divided by 2. We're going to have a negative 6 minus 2 divided by 2. So x equals negative, oh, that's an equal sign, sorry about that. Looks kind of funky. Negative 6 plus 2 over 2, and then we have x equals negative 6 minus 2 over 2. And then now we can simplify the top and divide by the bottom. So negative 6 plus 2 is negative 4. Negative 4 divided by 2 is negative 2. Then negative 6 minus 2 is negative 8. Divided by 2 is negative 4. So our two answers here are negative 2 and negative 4. However, there's a phenomenon that happens when we work with rational functions, and that is sometimes we'll have what is called an extraneous solution. An extraneous solution is where, yes, we solve for it and we get these two answers, but maybe one of them or our extraneous solution, doesn't make the equation true. So what we want to do, in fact, we should make this step 4, is check for extraneous solutions. Check for extraneous solutions. And boy, let me see if I could write that a little nicer so you guys can have it in your notes, because the spelling is, so it's extraneous. There we go. Extraneous. And extraneous solutions, again, those are just solutions that, although we solve for it and get it, it doesn't necessarily make the equation true. So how about we plug both of them in and see if we get an extraneous solution. Let's see here. I'm kind of running out of paper here. So our original function was 5x plus 2 over x plus 10 equals x plus 1. And our solutions that we got were x equals negative 2 and x equals negative 4. So all we're going to do here is just plug it in and see what we get. So let's see here. Let's just start. Let's start with negative 2. So 5 times negative 2 plus 2 over x plus 10 plug in a negative 2 for x, sorry. Negative 2 plus 10 equals negative 2 plus 1. So let's simplify here. This is 5 times negative 2 is negative 10. Negative 10 plus 2 is negative 8 over negative 2 plus 10 is negative 8 equals negative 2 plus 1 is negative 1. And let's see, negative 8 divided by negative 8. Well, anything divided by itself is just 1. So 1 equals negative 1. And is this a true statement? No, it's not. Because 1 does not equal negative 1. So this, negative 2, is extraneous. Let's try negative 4. Oh, I don't know why I changed markers here. Okay. So 5 times negative 4 plus 2 divided by negative 4 plus 10 equals x plus 1, so negative 4 plus 1. Well, 5 times negative 4 is negative 20 plus 2 is 18. Oh, sorry, negative 18. And then negative 4 plus 10 is 6 equals, let's see, negative 4 plus 1, that's going to be negative 3. Negative 18 divided by 6 is negative 3. So yes, negative 3 is going to be negative 4 is our answer, while negative 2 is extraneous. Okay? So technically what that means is negative 2 is not an answer to our problem. Okay, let's do another example. So we have 4x plus 14 divided by x plus 4 equals x plus 5. So first let's get rid of this fraction. So let's multiply both sides. Multiply both sides by what we have on bottom. So x plus 4. Let's see here. So we're going to have, so this cancels out here. So we're going to have 4x plus 14 equals x plus 5 times x plus 4. Now we're going to want to multiply this on the right side. Remember, now we're going to want to simplify and then move everything off to one side. So x times x is x squared. X times 4 is 4x. 5 times x is 5x. And 5 times 4 is 20. And over here on the left, we still have 4x plus 14. Well, now we can combine these like terms. Remember, when we FOIL, we generally have like terms. So let's combine those. So we have 4x plus 14 equals x squared. 4 of something plus 5 of something gives us 9 of those somethings, plus 20. And now to move everything off to one side. So let's subtract both sides, or sorry, 4x and then negative 14 from both sides, because we're doing the opposite operation, right? They're both added, so let's subtract both of them. So minus 4x minus 14. See, that's going to give us 0, which is what we want on the left side. And then we have x squared. 9x minus 4x is 5x. 20 minus 14 is 6. And then now we'll plug this into the quadratic formula. So again, I'll just write the quadratic formula for us. And let's go ahead and define our a, b, and c. So a is the coefficient of the x squared term, that's 1. B is the coefficient of the x term, that's 5. And C is the constant, so that's 6 in this case. So by plugging it in, we're going to get x equals negative b, so negative 5, plus or minus square root of 5 squared, minus 4 times our a, which is 1, times c. So 4, let's see, so 4 times 1 times 6, all over 2a, 2 times 1. So simplifying this, we're going to get negative 5 plus or minus the square root of, see, 5 squared is 25. Negative 4 times 1 is negative 4, times 6 is negative 24, all over 2 times 1, which is 2. And then we can continue simplifying under the square root, so x equals negative 5 plus or minus square root of 25 minus 24 is 1 divided by 2, and we can continue because 1 is a perfect square. Remember, 1 times 1 is 1, so the square root is positive and negative 1. So x equals negative 5, let's see, plus or minus 1 over 2. And this is where we will split it up into two equations. So one is going to be x equals negative 5 plus 1 over 2. And the other one's going to be x equals negative 5 minus 1 over 2. Simplifying, we can get negative 5 plus 1 is negative 4. Negative 4 divided by 2 is negative 2. Negative 5 minus 1 is negative 6. Negative 6 divided by 2 is negative 3. So now we have these answers to check. Well, now we have these two answers, so now let's check for extraneous solutions. I am going to pause the video. You might see, well, you might see it shift around a little bit. That's why, because I need to actually start our meeting for today. So, all right, class. So I'm back. Let's see. What were we doing? We were checking for extraneous solutions for this one when we got negative 2 and negative 3. So let's see here. Our function was, or our equation rather, was 5x plus 2, x plus 10 equals x plus 1. Okay, wait, no, that was the last one. I was looking at the wrong one. My bad. 4x plus 14 over x plus 4 equals x plus 5. Okay, and our two answers we got was negative 2 and negative 3. So let's go ahead and plug those in and see what we get. So we have 4 times negative 2 plus 14 all over negative 2 plus 4 equals negative 2 plus 5. So negative 4 times negative 2 is negative 8, plus 14 is 6, over negative 2 plus 4 is 2, and we get, let's see, negative 2 plus 5 is 3, 6 divided by 2 is 3, so 3 equals 3. So that's negative 2 is a good solution here. Let's now check negative 3. So we have, let's see, 4 times negative 3 plus 14 over negative 3 plus 4 equals negative 3 plus 5. So 4 times negative 3 is negative 12. Negative 12 plus 14 is 2 over negative 3 plus 4 is 1 equals negative 3 plus 5 is 2. And then let's see, 2 divided by 1 is just 2. So 2 equals 2. And so we have, again, this is also a good solution. So in this case, in this example, there aren't any extraneous solutions. Both of those answers will work for us. Okay, let's go over one more example. So now we have 3x plus 9 over x plus 3 equals x plus 4. So again, first step, let's try to get rid of that fraction. So let's multiply both sides by x plus 3. So that will cancel this out. So we're left with 3x plus 9 equals x plus 4 times x plus 3. And then we're going to FOIL this. So we're going to multiply these together on the right side. So we're going to have 3x plus 9 equals, let's see, x times x is x squared. X times 3 is 3x. X times 4 is 4x. And 4 times 3 is 12. And again, we have two like terms here in the middle, so we can go ahead and combine those, which will leave us with 3x plus 9 equals x squared plus 7x plus 12. And then let's subtract from the left side, so to get everything onto the right side so that we have 0. So minus 3x and minus 9, minus 3x minus 9. And have 0 equals x squared, and 7x minus 3x is 4x. 12 minus 9 is 3. And now we can use the quadratic formula, just so we have it for reference. Okay. So let's define our a, b, and c. A is the coefficient of the x squared term, that's going to be 1. B is the coefficient of the x term, that's going to be 4. And C is our constant, so that's going to be 3. And now let's go ahead and plug it in. So x equals negative b, so negative 4, plus or minus the square root of b squared, so 4 squared, minus 4. And that this 4 is in the formula. So 4 times a times c times 2, or over 2 times a, 2 times 1. So simplifying, we're going to get negative 4 plus or minus square root of, I like to do this part first, 4 squared is 16. And then I like to do this part all at once. Negative 4 times 1 is negative 4. Negative 4 times 3 is negative 12, all over 2 times 1, which is 2. And continue simplifying under that radical. Negative 4 plus or minus the square root of 16 minus 12 is 4, over 2. And then we can take the square root of 4, which we know is 2. And we'll posit negative 2, over 2. And then we can split it into two equations now, where we're going to have x equals negative 4 plus 2 over 2. And we'll have x equals negative 4 minus 2 over 2. So simplifying the top one, negative 4 plus 2 is negative 2. Negative 2 divided by 2 is negative 1. Negative 4 minus 2 is negative 6. Negative 6 divided by 2, negative 3. So we have negative 1 and negative 3. So now let's go ahead and check for extraneous solutions. And I believe we have some room right down here, which we can do it on. So let's see. Our original function's up here. So let's see, what am I doing? I'll use green for this. So let's plug in negative 1 first. So 3 times negative 1 plus 9 over negative 1 plus 3 equals negative 1 plus 4. So let's see, on the top we're going to get negative 1, or 3 times negative 1 is negative 3, plus 9 is 6, over negative 1 plus 3 is 2, equals, let's see, negative 1 plus 4 is 3, 6 divided by 2 is in fact 3. So we know that negative 1 is a good answer. It's non-extraneous. Now, let's do the same thing with our negative 3. So 3 times negative 3 plus 9 over, let's see, what am I doing? Negative 3 plus 3 equals negative 3 plus 4. I already see a big problem here. Remember, we can't divide by 0. Look what's going to happen. 3 times negative 3 is negative 9, plus 9 is 0. Negative 3 plus 3 is going to be 0, equals 1. Even if the top did equal 1, this can't happen because we are dividing by 0. So, negative 3 is, you guessed it, extraneous. Okay? So our answer in this case is only negative 1. So that's all I have for y'all today. Get started on the worksheet. Let me know if you have any questions, okay? Have a good day.